talk about today. But let's get started, because I think we got a bunch of stuff going on. So I'm going to talk about, I'm going to take you on a journey. And as I go down this journey, I don't expect everyone here to necessarily agree with me, or maybe they find this interesting, or maybe they find it just pure insanity. That would be awesome if we would have a conversation about that insanity, preferably with drinks, which is a happy hour later. But we're going to take this journey. We're going to talk a little about serverless and its effect on things like reliability, DevOps, site reliability engineering, how it changes things. We're going to talk a little bit about this notion of cost and how we think about how that fits into all this. We're going to kind of use this kind of crazy idea of combining finance into DevOps thinking, and then I'll make some wild-ass guesses about the future, right? And then hopefully we just have a really good time as we walk through this. Sounds good, Erik? All right. So let's start with a conversation about what is serverless. So there's a lot of people who talk about, oh, serverless is this, I only pay for idle, I don't pay for this, it's functions as a service, Amazon Lambda, Google Compute functions, et cetera, it's all nonsense. I think there's really only one reason, one thing that we really, when we think about serverless, and this is what I think about, is that serverless is a technology abstraction that enables you to deliver business value faster. That's it. And somehow we got to let the conversation get kind of obsessed with functions of the service, and that's a little bit unfortunate. I'll get into a little bit more about why that's important. But I wanted to share something that everybody here has never seen before, right? Which is a live view from one of the serverless data centers at AWS. This is exactly the future that we envision for ourselves. So, top secret, if I get carried off the stage later and sent off the black site, it'll be because I showed this image. Seriously, this is the vision that we have, a lot of us inside of our companies today. Right? And ultimately, why did we go down this path? Because we didn't want to have to manage all that stuff. Right? We didn't want to manage all that stuff because we wanted to get to the customer value that we were delivering faster, build the things that were more important to our customers, versus managing all this stuff. Right? Of course, we inherited a whole bunch of other things that we now have to manage. Virtually, via APIs. So, what do I mean when serverless is more than just functions and service? Right? So Ben Keogh is a cloud roboticist at iRobot. He first put out this idea that serverless was a spectrum. And he used this idea around spectrum to get people to think a little bit beyond just functions of service. And this is just focused on AWS. You could draw the same diagram for Google or for Azure. But think about all the services that your cloud provider gives you. Everything on the far-hand right side, less operational burden for you. Everything on the, let's say, that side, more operational burden. Right? This is a better way to think about serverless. And as you kind of cross over that 50% mark, you start to really get into the serverless, what I would call the serverless territory. Less operational burden, all kinds of other things that you have to think about. Now, we're all still here. We still have things that we want to achieve. So how does that change things? So first, let's think about the cloud not as an abstract place where computers run, but let's think about the cloud as an operating system, and let's think about serverless as its native code. Okay? Only challenge with that, of course, is a lot of us lifted and shifted our way into the cloud. We took the same virtual machines that were running in our basement and we moved those into the cloud. We can't do that with serverless systems. We can't lift and shift our way into that world. We actually have to rethink, re-architect our applications. And that also implies that you have to change your culture and process along the way as well. So how do we build reliable serverless systems? So this you might have seen this quote before from Bert Vogels, the CTO of AWS. He kind of famously went out and said, everything fails all the time. Now imagine your CTO came in and said, hey, we're going to build one of the world's largest computing environments, and everything that we build is going to fail all the time. It'll be great. How many people would hazard a guess that that person could have their job for a long period of time? So that's exactly what he said. He stood up in front of the world and he said, hey, we're going to build this new type of computing environment, and everything's going to fail all the time, and actually it's going to be wonderful. It's going to be great. And looking around at all of us who have jobs, it absolutely is great, right? Because everything's failing all the time. So if everything's failing all the time, and I can't lift and shift, I have to change how I build my systems, I should really rethink my culture and process, well, what does reliability even mean in this context? And that's one that sometimes we need to just start with a very simple definition of what we're talking about. So I think reliability is best thought of as the trustworthiness of a system's ability to delight the customer, right? Not necessarily us. Of course, none of us really want to work on a flaming dumpster, fire of epic proportions. We want to be delighted as well, but ultimately we're doing this to delight our customer. Right? And the trustworthiness of a system to be able to do that, well, I think that's what reliability really means. So we have this concept of serverless. Right? How can I deliver business value, customer value as quickly as possible? This new concept of reliability, how trustworthy is my system's ability to do that? And a new way of thinking about how I operate in an environment where everything's failing all the time by design. So there's two different forces that kind of guide us. And I've broken these two pieces out. One, I would refer to DevOps really as culture, site reliability engineering as practice. And if you break them out, there's a lot of different books and thoughts and processes and blog posts and people fighting in the alleys about what it all means. But I did my best to break it out like this. And on the culture side, we're trying to eliminate silos, accept failure, think about mean time to recovery, how fast can we move, measure everything. On the site reliability side, we're more focused on the block and tackling and activities that we're going to do on a day-to-day basis. So how do those forces that drive reliability and what we're managing in the world today change as we start to build more cloud-native or serverless systems? Hopefully you're not thinking this is the Titanic, but you're just aware that there's a lot under the water, right? Although if you do it wrong, you could be in the Titanic. That said, they have excellent deck chairs, and no matter how you reorganize them, it's going to be good. Right? So the first step, of course, of serverless is just the happiness is you have to let it go. Right? We all have heard the jokes about managing treat your servers not like pets, but like cattle, and maybe there's a vegan version of that analogy, but the ultimate thing is to just not even think about them anymore as pets or cattle or any object whatsoever, is to just let them go. Let somebody else worry about it. Let Amazon worry about it. Let Google worry about it. So some things stay the same, some things change. So if I take those concepts out of the SRE side, things like availability, efficiency, capacity planning, monitoring, those change. Other things stay the same. So availability. What does availability mean when it's not my responsibility to keep the system up anymore? Right? Now I have to think about what are the SLAs and the promise that my provider is giving me, my ability to auto-scale, my ability of the system to auto-scale under load. Latency, still my problem. I still have to write good code. Performance is harder to understand because the call graph of my application now becomes an infrastructure graph that's spread out all over. Efficiency, it's not so much about efficiency anymore, it's about cost, and we're going to talk a bunch about that. Change management, more tracking, less management. Monitoring becomes this new fancy word, observability, which we've all probably been struggling to have a love-hate relationship with, but it's actually kind of a cool thing. Congrats, we're all still in call. And then capacity planning really is service limit planning. What limits am I going to hit when my system starts to scale up? They're out of my control, unfortunately. And then provisioning, automate everything. Nobody's clicking around in the cloud console, right? Okay. So, I think I've got everything in order. Maybe I don't. So cost replaces efficiency. So think about this. So on one hand, we've all heard the story that if I'm using Lambda, it costs me like $1 a day. Why do I even care? Well, serverless is a spectrum. We've got lots of different components now. I compose my application of lots of different services, and they all feed into each other. And I might be spending $1.79 on my fast cost, but if I add up everything else that I glued my application together, it's actually a pretty expensive application. And it's also pretty common for CloudWatch logs to strike while you're not looking. That's just one particular area. But we have to think about the entire system. This system may be very efficient, but may be very, very cost ineffective. And that's why it's important that we think about that, because we don't want to put ourselves out of business. Observability replaces monitoring. So think about observability as really, our ability to measure the state of a system, be able to determine from the analysis of its outputs, right? So you have to be able to observe it, and then you have to be able to analyze its outputs to figure out what's going on. There's a lot of different factors that go into this, but you have to be able to do this analysis without a prior knowledge. You have to think differently about how you monitor the systems. It's not just about logs and log analysis anymore. Right? Dumping all your logs to one place is about to solve your problem. Nor is creating a bunch of dashboards that you stare at all day long. And this is the most disturbing image that you can find on the internet for staring at dashboards. This is not analysis. The system itself needs to be rid of this analysis. Otherwise, you don't see it. Service limits replaces capacity planning. So capacity is built in, right? Infinite scale, but serverless has limits, has constraints. All the services you use have constraints, and guaranteed you will hit them once you're in prod, under heavy load, when you least expect it. This is one of the reasons, by the way, that I think the whole notion of testing in prod is becoming more and more important, particularly in cloud-driven architectures. There's just no way to get at these problems until you are there running in prod under load. There's a couple of examples. Think about how the types of limits the AWS Lambda has, for example, limits that API Gateway has. Some of them are fixed, some of them are configurable. The invocation patterns, or how you wire all those components together. Sometimes it's async, sometimes it's synchronous. You have to think about how those limits affect the type of system you're building and how it will behave under load. All right, now let's talk about DevOps. What's the serverless effect on DevOps? So, I used to have a more contentious version of the slide. Maybe this aligns with a little bit of what we were hearing talk previously. But I believe strongly that DevOps wasn't some happy collection of developers and operations people getting together and skipping down the road. It was a hostile takeover. How many people in the room would identify as a developer? How many people would identify as an operations person? How come 100% of you didn't raise your hands? Okay. We're all DevOps people, we're all developers, we're all operations people, and this is absolutely critical if you start to build a more cloud-native or serverless infrastructure, right? DevOps eats ops. At the end of the day, you have to do both together. Effective serverless engineering teams, they have to take ownership of this. They have to be part of this process. They cannot outsource it to anyone else. They have to embrace ops just as much as ops has to embrace development. It's very much intertwined. Mean time to recovery is better than mean time before failure, right? This is absolutely fine. Everything's failing, and that's okay. If you're, in my company, we have a saying that we're always 5 minutes away from production, which means if something's broken, we're 5 minutes away from fixing it. Okay? Something's on fire, we're 5 minutes away from putting that fire out. And we try to live that mantra every single day. And what it enables us to do is not spend a lot of time trying to make something perfect, but it allows us to move faster. It allows us to do things that maybe sometimes might seem a little risky. But ultimately, and thankfully, this is if you're building pacemakers, that might not be for you. Right? But for us, that makes a lot of sense. I think it makes a lot of sense for most people. So trick question. It's 6 p.m. It's Friday. Is it time to deploy? Yes? No? Yes. It is absolutely yes. Thank you. Thank you to the yeses. Right? And you know why it's absolutely yes? If you don't feel comfortable deploying to production at 6 p.m. on a Friday, then you definitely do not understand or have confidence in the system that you've built. It's as simple as that. If you are hovering over that button and going, you know what, I'm not really sure what's going to happen if I do this, you haven't thought long and hard about how you built out your systems and made them resilient to this world that is always failing. Right? They should be able to react to that failure. They should be able to understand it. And they most certainly shouldn't keep you in the office late if you do a deploy. If something fails, you should be able to roll back. Maybe you're 5 minutes away from production too. get to cost, because cost is the one piece that, when I speak to a lot of engineers, a lot of folks in the DevOps world, sometimes I hear things like, I don't care about cost, or I don't even know about cost. Cost isn't even something that I even know goes on. It's handled by our CFO, right? Well, in a world where you have infinite scale, that means you also have to have something else. Infinite wallet. Does anybody have infinite wallet? Right. If I can do it in AWS, Amazon for damn sure wants to charge me that I can do it. Right? And we're not having this conversation among ourselves when we build our systems. At what point are we going to degrade our customer experience to save the wallet? Right? Now, you might be saying, well, this is something that we just don't want to think about. Customer experience at all costs. This is total, absolute insanity. Well, it wasn't too long ago that decision, we were going to degrade the customer experience, was made for us by people outside of this room. And now we're empowered to actually make that decision. The CIO got together and they figured out, hey, let's spend $3 million on a bunch of boxes, we'll put it in the basement, we'll amortize it over 3 years, it'll be great, and that's all we need. And then when the systems didn't scale up to that, the developers went back to the code, figured out how to make it work within those constraints. Now we operate in a world where there's no constraints. Right? We may already be there, or maybe just around the corner, where we will find ourselves in a world where there are literally no constraints on what it is that we can build, or what we're building and how it can scale. Except for one constraint, which is how much money is in our wallet. Right? That will be, in a very short period of time, if it's not already here, the only constraint that we need to think about. And ultimately, a system that puts your company out of business is the least reliable system on the planet. So the way I like to think about it is that cost needs to be what I call a first-class metric. It's the most expensive thing that we're not monitoring. We're not treating it as a source of very important real-time telemetry. So what is a first-class metric? So it's real-time, there's context, you can measure it, and you have a clear definition of good and bad. Very simple definition. Okay? So coming back to this chart for a second, right? How would we even know this is happening? Are we looking at our system from this level? We probably understand transaction volumes, we probably understand uptime and availability. Maybe we have some synthetic metrics, so we kind of understand what our customers are feeling in the moment. But how would we know this is happening? How long would it take you to know that your site is down, for example? Right? A few seconds? Everybody get paged pretty quickly? I love that we still use the word page. How many people actually carry an actual page? I know. It's going to be like the old phone that you used to carry around like this. Halloween's coming up. I need to get a big pager. Probably be a few minutes, so maybe a few seconds as well for customer transactions. It's generally about a month, maybe a quarter, before you knew you just spent 50 grand. Right? True story, I worked with one client, an internship program came in, worked for 3 months, no monitoring, just said, oh, here's Amazon account, go nuts. They came back at the end of the program, and they said, this is a super successful internship program. Look at all this great stuff that was created. Then the CFO walked into the room, and he said, that team spent $1 million. Never do this again, right? And they literally spent $1 million. Nobody had their eye on the ball. Right? We have to change this. Cost needs to be a first-class metric. Because it tells us stuff about how effectively we build our systems. We don't have constraints anymore that used to push us to build more efficient systems, build more performance systems. I can just throw more compute that scales up instantly as a problem until I run out of wall. Okay. So with me? That cold is here. I feel like we need to do some calisthenics. So let's make some wild-ass guesses about the future. I don't know what the hell we're going to call this thing. FinDevOps sounded kind of cool at the time. I think it's kind of cool still. But honestly, I think it just needs to be DevOps. Just the way I think DevSecOps doesn't really need to exist. Security needs to be part of that process too. This needs to be part of what we do and what's important to us. So I think in the future we're going to treat cost as a first-class measure. I think it's going to be the one thing that guides us to build better systems. We're going to use it as a competitive weapon when we go out and build products that are better than our competitors. We're going to use it to be more efficient in everything that we do. And we're going to start to think about our cloud spend as not some sort of money that I'm shoveling into this giant boiler in the basement, but actually an investment, right? And what do we expect from an investment? We expect a return on that investment. When I put $10,000, $100,000, $1 million into my AWS bill, I should be getting that much money back, or hopefully an order of magnitude more. And then the question is, well, how come we don't already know that? Right? We need to have this deep understanding, and we should, in the future, have this deep understanding between the relationship between customer value and cloud spend. For those working at software companies, how tight, go back and ask this question, how well do you understand the alignment between what the customers are paying you for your products and how much it's costing to run the systems that they're using? Which of your customers are the most expensive that might actually be putting your entire business into risk? Because ultimately it comes down to this. All of us here have enormous power. We have never been in a more powerful, enlightened period of time in our existence. I don't know what comes next, but this is absolutely true. Every line of code that we write is a buying decision. Whether it's Python, or Terraform, crazy CloudFormation, something a little bit more sane, it doesn't matter. We're making buying decisions. The question is, are we making informed buying decisions when we do that? And I think if we look out even farther in the future, 3 years from now, it's going to be absolutely crazy that we didn't monitor these things as part of our operations. Right? What's the baseline cost? If I have no customer load, how much money am I spending? That should be ideally as low as possible. What's my cost per customer transaction? How much do those shared multi-tenant systems take out of my system? How much is my R&D costing me versus the things that are deriving value to my customer-facing products? Does the load of my products linearly grow with my bill, or vice versa? Because ultimately, where I think this concept of FinDevOps, or cost is the first cost measure, is going to take us to a world where cost of goods sold, COGS, is what really matters to us. And the FinDevOps makes this possible. Because now we go back to this chart and we think about where we're operating. Well, who cares? We're rich. Right? It doesn't matter that I spent $789. Maybe I could probably fix that. But still, the profit of this application is huge. And that's ultimately what matters. That's what we want to achieve when we think about aligning cost with all these other aspects. Because as we start to embrace serverless, or even cloud native, or containerized infrastructure, where the load maps much more cleanly to what our customers are doing, we're going to find ourselves in a mode where the only constraint is how much money we have in our pocket. So with that, thank you very much. I really appreciate it. Like I said, I don't expect this all to agree, but